Hello all. I hope you are all keeping warm wherever you are. My name is Amina Christensen and I am the marketing manager at Comfort. I would like to welcome you to the first webinar of our webinar series, Unlocking the Future of IoT Connectivity Trends and Predictions. Thank you for joining us today. We will have two presenters, Martin Noor, CTO at Comfort, and Henrik Holm, Chief Commercial Officer at Sensorita. If you have any questions, please do use the Q&A section and your questions will be answered at the end of this webinar. And now I would like to introduce Martin Noor, CTO at Comfort, who will uncover emerging IoT connectivity trends and interesting case studies.
Thank you, Amina. Yes, let's try to unlock the future of IoT, make some trends or share some trends and make some predictions so that you can better navigate this fast evolving space. So the agenda looks like this: a brief introduction, look at the trends, predictions, and how to navigate the challenges and opportunities before we round up with some real-world case studies and leave the floor to Sensorita and Henrik. So what is the Internet of Things? I fancy this definition. In essence, it just describes it's a set of devices that are able to communicate with each other and other systems using a network. In this today, we will talk about cellular Internet of Things, meaning that the communication network is a mobile network or cellular network. Such a cellular IoT network and use cases can look like this. We have a landscape here with several use cases, and we focus on a connected camera where there's a camera and a modem with a SIM card within it in step 1. It's able to attach to the cellular radio access network in step 2, which in turn sends the signals to the core network. Now the core network authorizes the connection, produces the correct service, and passes the signal on to the partner application or business system, typically in the cloud or at the customer's backend system. The customer is able to manage their fleet of SIMs using a connectivity management platform. So this way they can pause SIMs, they can start SIMs, and they can bundle them together for billing purposes in a pool, all eating from a shared pool of data. Another way of looking at the very same thing is from the customer perspective. How does the network look from the customer? Here you see a number of devices on the left side, which belongs to the customer's virtual private network. And via this virtual private network over mobile networks, it's able to reach the customer servers and the devices that should have access to this customer network. So this illustrates that for the customer, he only sees one segment of the network. So IoT is really not the ability that any device can communicate with any device. It's rather the ability to produce hundreds of thousands of networks where the right devices are able to communicate with each other and other systems. And this is in a way specified by the organization. Now, let's look at what is moving and shaking the IoT space. First of all, well, the SIM has been with us for a long time. It's undergoing steady evolution, but now we can talk about revolution, some would say. As you may well know, the subscriber identity module is the identity element that ensures that you have access to the correct network service. Only the correct users get access to the network. And it's not just a SIM, it's really a key to optimize the device and the service. It has applets on it that can optimize the connectivity, which may be useful in many cases. The SIM has a set of important parameters. It's physical. What are the size requirements of the SIM that can impact the device itself? What are the power consumption? Also longevity, the quality of the SIM, the sturdiness, how long is their lifetime? How many rewrite operations does it support? Does it support to reside in an environment with a lot of vibrations and very cold temperatures, for example? And also the logistics or process support. What are the requirements from the production line and supply chain logistics? For example, how do you easily insert the SIM into your device. And then there's lifecycle management after production. How do you manage the SIM? Are you able to change the behavior of SIMs, such as changing the profile, governing the SIM profiles? We'll get back to that in a minute. So the SIM types that are most prevalent today, it's UICC. It's the traditional SIM that we're used to inserting in our cellular phones for last decades. But you also have the eSIM or embedded SIM, which is a solderable SIM. So in the industrial use case, it's more practical to solder the SIM onto the chipset and device in the production process than manually inserting it. Also, you have SIMs that can be UICCs or eSIMs, but are eUICCs. Those are SIM types that can hold many SIM profiles. And at the end, you also have quite recently the integrated SIM or the iSIM, where the SIM is not a physical device that you can touch, but rather resides in a secure zone on the chipset in a tamper-resistant element on the system on chip, typically the chipset. And this is very useful for large-scale projects. It still requires a process to transfer the active SIM profile onto the iSIM, but it has potential to be easier. I mentioned eUICCs. So an eUICC SIM can change profile over there. So you can change the fundamental properties of the SIM so that you can improve the cost and the coverage, maybe the quality and the mobile technology. And you can even provide your connectivity service provider. And the RSP is the only way to change your CSP without physically changing the SIM card in the device. Now, there are several standards for RSP. The first one is the machine-to-machine RSP, which was made for IoT. It's a very good standard, but it is a bit complex. You need a lot of pre-integration between the CSPs in order to make this happen. And everything here is controlled by the CSP and is thus push-based. Also, it has some limitations for LPWA use cases. I'll come to what that is in a minute, but it relies on SMS and it's not really suited for LPWA. And also with the advent of eSIM or advent of iSIM, there's no support for RSP for iSIM in the market thus far. So the consumer device manufacturers, they moved on to make a consumer RSP, which is pull-based. So the swap of profiles is initiated on the edge, typically by the consumer using a user interface. And that's a luxury we don't have in IoT. The devices are usually spread all around the market, and you don't have a person to operate it. So now we see the advent of IoT, remote SIM provisioning, which adapts the consumer RSP to IoT use cases. And this standard is much more flexible and supports large-scale use cases. Also, it supports LPWA and the more advanced protocols for IoT. It's coming. And this solution will be completed, standardizations and certified in 2024, but there are some pre-standard solutions that exist today. Important to note that when you are going to choose a SIM card, you have to choose which standard, because you don't have one SIM card that both supports M2M RSP and IoT RSP. So if you're interested in this topic, please contact us at Comfort. We have a long experience of dealing with the RSPs. Also, the devices has been very important from the start in the M2M space, but it's becoming more and more important. And when you think of it, when you design an IoT solution, the IoT devices are a key part. It doesn't help that your connectivity service providers supports 5G if your device only supports 2G. Also, if you want to design a new physical product from bottom up, you have to consider the fundamental properties of the chipsets and the modules. So you really need to ensure that the connectivity and the hardware work well together. So how do you do that in practice? Well, at the start, you need to contact someone with experience if you don't have it yourself. There has to be a knowledge base, what works, what does not work. You have to think of the secure design from the start and also be able to do proof of concept testing. And you also have to think about how will you manage your device during the life cycle? How will the firmware update process work? How will you handle failure scenarios? And you also have to think of the end of life at the start of the project. How do you plan to do a proper decommissioning? How do you turn the device off? How do you delete the credentials and the configuration on the device, which, unless you take care of it, could be a security threat. Now with especially the iSIM technology, we see more and more plans to bundle hardware and connectivity. There's iSIM, but there's also another SIM type, more software-based, also referred to as integrated SIM, called new SIM. And if you can buy the SIM card or the SIM functions with the device, then of course you can improve logistics at scale. So this is really interesting development and has a great potential. There are still early days. Things are moving in the space, so we will follow this closely, and we'll be happy to guide you in this space. But a word of caution is that be very careful not to use proprietary solutions unless you know what you're doing. At Comfort, we recommend use of standard-based and certified and interoperable solutions so that you can have the maximum security, compliance, and avoid lock-in. Another area where technologies has evolved over the years is naturally the radio access technologies. So the devices and the connectivity service providers support different radio access technologies, meaning 2G, 3G, 4G, and 5G variants. And this obviously has impact on the connectivity properties. So there are different properties when it comes to coverage, which frequencies are allocated, and which roaming scenarios that are supported. And also these technologies are in different phases of their life cycle. Some are being introduced these days and may have not yet the best coverage or roaming agreement, haven't reached roaming agreements with all the network operators, and others are being refarmed or even sunset. They vary a lot when it comes to data rates supported, where 5G supports up to gigabit throughputs. And also latency is varying between these technologies. And also the latest supports CUPs, so you can more flexibly place the gateways where you want them. And this gives you some tools to support data sovereignty requirements. For example, if you want that the user plane should reside within a country or a certain geographical area. Since 2017, the technologies LPWA, low power wide area, has been around. NB-IoT and LTM are two versions in that category, and they're really optimized for IoT. So they have a lower power consumption, which is great for battery-powered devices. They have improved signal penetration, which is great if your devices shall reside in a basement or in a ducts underground. They have simpler hardware design, which reduces the cost. However, there are some limitations on SMS voice scenarios. The roaming footprint is good, but not yet as good as ordinary 4G. And there are limitations on bandwidth and latency. So even though they are great for many use cases, if you really want to have the best available LTE global footprint, you may want to make use of that, you could consider the LTE Cat 1 or LTE Cat 1 bis in some cases. So the point is really one has to consider the radio access technologies, and things are evolving from quarter to quarter in this space. Now, a mega trend that we study with great interest at Comfort is the combination of AI, IoT, and the cloud. We see that a lot of use cases are in the operational technology, automation. And where you have a pattern that you have sensors in the physical world that transfers the data to the cloud, and their AI is able to process the data and make some recommendations or decisions. The data is traveling back to the devices, and you do some control or automation in the physical world. And this can, for example, be a case of road traffic management, where you have connected cameras transferring images and videos to the cloud, and there's an AI algorithm making optimization recommendations. For example, what should be the speed limit, and what should be the frequency of red, yellow, green lights, and where should the traffic be directed in case of an incident. So the benefits are quite obvious. There are business benefits to the one providing the solutions. If the solution is effective, it improves the user experience, spending less time in queue. And there's also sustainability gains. By using the roads more efficiently, there's less need to buy new roads or build new roads rather. And by using this, we can also expect that the operational technology and the AI itself is improved by doing this over and over and learning from that process. So if you zoom out, we see that AI actually drives cloud and IoT use cases, because a lot of the use cases can be too complex or not cost efficient to do manually or without the power of artificial intelligence. But also conversely, IoT and cloud drives AI, because AI, as we all know, needs a lot of data for learning, and it's a lot of compute power, and that can be delivered by cloud, either centralized or edge clouds. We also now believe that there's a catalyst effect, that generative AI and new AI frameworks makes it easier to use AI and then accelerates this positive cycle. So really exciting times ahead. It's time to make some predictions about the IoT connectivity space. So there's been a trend for some years that we believe will continue, and that's the specialization and consolidation of the players in the market. We firmly believe that you need specialized IoT companies to best navigate the fast-evolving IoT connectivity space. At the same time, these specialists dealing only with IoT connectivity needs to be a certain scale. You need some scale and scope synergies to keep healthy margins and be able to develop new features as the market requires. So typically, the mobile virtual network operators, MVNOs, has this capacity, and they specialize only on the IoT market, and usually they're able to provide good solutions. As a customer, you should really assess the robustness of your suppliers and also consider their sub-suppliers. But because it can be in this fast-moving IoT space that there are some changes on the sub-suppliers part that affects you as a customer, and that may not always be what you're interested in. So do your due diligence when selecting a connectivity service provider. Let's look at the numbers. There are several analyst firms predicting the growth. I guess in IoT space, all predictions may seem a bit modest compared to the original predictions made 10 years back, which were quite exaggerated. But I think now we have quite realistic projections from different analyst firms, and they show a really solid growth. We're already at 2 billion cellular IoT devices connected, and it's expected to grow to 5 billion the next 5 years. So this forecast is from Transforma, but there are other analyst firms doing the same thing. We can see that the growth will mainly be on 4G devices and 5G. Included in the 5G here is low power wide area, because it's a 5G supported, or it's a 5G standard. In terms of market value, IDC predicts or estimates the market to be at 6 billion euros and a healthy growth of 25% going forward. Now, that is very interesting, but at Comfort, we believe that most of the value is actually outside the connectivity space, but rather to the customers and the end users of the product. Because IoT is, after all, an enabling technology, but the customers that makes use of it will create great business value. The end users will benefit from time, convenience, safety, and thus better flow in the life. And the society at large benefits from sustainability gains and ESG gains of IoT connectivity. So an example could be these days if you happen to crash a modern car, then an e-call will contact the ambulances before you reach your mobile phone, and that can be very handy in that situation. Or there are technologies that are required for sustainability. That can be wind turbines. In order to operate those efficiently, you typically need an IoT solution in order to monitor and optimize them. There are so many use cases for this. We don't have time to go into details, but if you look at who gets the value at Comfort, we hope and work so that you as a customer and your end users will make great benefit from this technology. Now, let's look at the challenges and opportunities ahead and try to navigate them. I've mentioned that the radio access technology is important, and then it's crucial to consider the aspect of sunsetting. As you probably know already, 4G and 5G are the prevalent technologies. It's because they use the frequencies, which is a scarce and expensive resource, very efficiently. They also enable new services, such as gigabit communication enabled by 5G. And this means that the old technologies are being refarmed, moved to other frequencies, maybe have less capacity, maybe reduce the coverage a bit, and eventually they are being retired or decommissioned. So in here lies a call for action. All customer organizations or anyone considering a new IoT project should evaluate the sunset roadmap, because it does have large geographical differences. What happens in one country doesn't necessarily happen in another country. And one should follow it a bit closely because there may be changes. A decommissioning is announced by an operator, but then they change their mind and delay the sunset by 2 years, for example. That can easily happen. And you need to consider what's the impact of your IoT installations. For example, if you have a device supporting 2G and 4G, well, it maybe doesn't matter if 2G is sunset. And also, in order to do this best, I think it's a good advice to work with your connectivity partner to ensure you have a smooth transition when you actually need it, and migrate in time, because it is time consuming to do changes in this space. When considering changes, you should also look a bit further on the horizon and see, okay, what will be the situation for the next 10 to 15 years? Maybe if you have to change devices, consider technologies that will stick around for a long time. If you want to read more about this, check out our article at comfort.no. Also, just mention briefly the opportunity of low Earth orbit satellites, LEO satellites. There are parts of the globe on the oceans and in remote areas, for example, US Midwest, where there's scarce cellular connectivity. And in order to get some connectivity there, also for IoT, then the LEO satellites offers global coverage. And the interesting part is that they are 50 times closer to the equator or Earth than the geosynchronous satellites. And they're also compatible with standards for cellular networks and devices. So 3GPP release 17 non-terrestrial networks enables them to communicate with the handsets and also communicate with the MVNOs and MNOs with mobile core networks. So that way they can act as a primary or a backup connectivity solution. So a lot of things happening in the space, quite exciting times. A threat which has been around, it's been #1 challenge for most IT projects for a number of years, and it's only increasing, is the security threat. Because there are a lot of malicious actors out there with considerable motivation and capabilities. You also have the fact that the IoT solutions have taken more and more importance in our society, so they're more interesting to attack. And an IoT solution consists of many elements a huge number of IoT devices that are typically outside the perimeters of the organization. So there are many attack vectors. So all the customers or IoT companies with IoT projects need to really adequately secure their IoT system. And to do this, you have to think security by design holistically from the start, use a suitable framework, and really ensure that your connected devices are secure, that the network solution is secure, and the data is secure both in transit and at rest. So one way to address the last part is Cloud Connect and VPN options. You have your devices and you really want to ensure that the communication to the core network and also from core network to the cloud is secure. So there you have the Cloud Connect option where you have dedicated fibers to ensure you have a predictable capacity, latency, and also that nobody can interfere with your data. So direct fibers going from the core network to the cloud. You can also have redundant IP connections from the core network to your premises, or you can use VPN options to create a virtual private network to ensure the integrity of your communication. And also in this solution space, you can also control the data flows. For example, ensuring that the end devices only communicates with the centralized systems and not between themselves, which can be a way to reduce the risk of a malicious malware spreading between the devices. Now let's round off with looking at what's happening in the real world. We see IoT connectivity implemented in nearly all verticals you can think of. On the upper left corner, you have the example of the energy sector where AMS, smart metering, has been around for 10 years, 15 years. So you have the meters sending the data to the provider and not relying anymore on consumers reading how much power they've used on their meter and sending it via SMS to the provider. And at the bottom right, you have healthcare, where you have really exciting solutions, such as ensuring patients take the right medicine at the right time. What's interesting is there are so many verticals and all of them have subcategories. So there are analyst firms specializing in this and they build case studies, libraries of use cases. So we have Transforma and IoT Now, Bleacham report, doing this, for example. And within a category or a vertical like smart cities, when you break it down, you see that there are so many use cases. So in this example, parking space monitoring is probably the biggest one within smart cities. And then you have road traffic monitoring and control, and then public information and advertising screens. So they may be the top 3 in this categorization, but there are countless others. And at Com4, we work with entrepreneurs and startups, and we see that it's really just the imagination and sometimes the business case that limits where IoT connectivity can be used. Towards the end here, I will just mention that when making an IoT solution, there are many things that you need to get right. It's better to get it right from the start. So our advice is to use a professional partner to navigate this IoT connectivity space. We've touched upon some of the elements listed in this matrix in this talk. I think in upcoming webinars, we'll touch upon several others. So the point of this matrix is just to provide a sort of checklist and ideas of things you need to consider in order to get off on the right start in this space. To draw some conclusions, I think it's clear that there are many innovations in IoT, and combined with AI and cloud, this will drive the IoT connectivity industry forward at a great pace. We find great opportunities for customers in all verticals. They can benefit from cellular IoT connectivity in their products and solutions in many ways. but do consider all the relevant elements of IoT connectivity and partner up with a specialist at an early stage. That's it from me. I will leave the scene to Henrik, representing the amazing bunch of people at Sensorita. Over to you.
Thank you very much. Yes, so hi, I'm Henrik. I'm from Cellular, and we build sensors and software solutions for the waste management industry. And while Cellular is a very young company, only about 3 years old, it's garnered a lot of interest from this market, becoming Startup of the Year at the Norwegian Waste Association's event last year, and getting customers like the City of Oslo and the Randstad. And I think that the reason that software solutions are becoming so interesting is something we need to really like zoom out to understand, and that's the fact that as a society, we are facing some huge challenges in the way we consume material. So we need almost twice as many Earths as we have today to keep our current consumption up. And that clearly isn't sustainable. So we need to move from a linear economy to a circular economy. And that is not an easy feat. It's what's often called a wicked problem, in that it kind of feels like all the parts need to work for any of it to work. But that's, we clearly can't give up, and so we need to try to fix these little parts to make them work. And one essential part is obviously, how do we take the resources that we've consumed and put them back into the economy? How do we kind of close the circle? And that responsibility falls to waste management. And that is an industry that is in many ways kind of the definition of a legacy industry. So this painting here is called the Scrapyard at Barcelona, and it's from 1903. And a lot of the big companies in this industry today, the people who are kind of leading the charge, they started at this time. They were maybe neighbors to this scrapyard, and the name of the guy who ran that scrapyard, his name is often still on the door. And so it's an industry that, you know, while it has developed a lot, while it has made huge strides, obviously, in how it handles our vast waste problem, it still has a lot of legacy elements in it. And one of those is how the input is handled. So this is a containers at a construction site. And the construction industry generate about 30% of the waste in Europe. And even though such a huge part of our waste comes from here and comes from these containers are essentially invisible. So when the waste company places it at the construction site, they kind of disappear. They don't actually know where they are because the construction site moves them around. They don't know what's in them. They don't know how full they are, and they don't know when they'll be back. And I think that is part of the reason why 58% of companies who want to use recycled materials in their products worry about the quality and the quantity and the availability, because there isn't a clear overview what's coming in to the circle. And so they can't rely on those materials to produce their new products. Then that means that instead of reusing, they use virgin materials, fresh materials from the earth. And that's obviously a huge challenge. And so at Sensorita, we want to try to solve that little part of the puzzle. We want to make the invisible visible. And the way we do that is through this. So this is the Sensorita sensor. It's mounted on large waste containers. It's designed to take the rugged environment that large waste containers are exposed to. It can take, extreme cold, extreme impact. It has an LTE module, so it uses mobile IoT to connect, so that it doesn't matter where it's placed. It doesn't need to have any infrastructure around it to connect. And it has a GPS sensor and a radar sensor. And I think everyone knows what a GPS does, but I think the question is, what is radar? So a radar sensor sends out electromagnetic waves that reflect back. And it's pretty well suited for open waste containers, because unlike some of the other technologies that are used in measuring fill levels, like ultrasound or lasers, it is very it's very good against interference like dust and snow and even morning dew, so things that could block a laser sensor, for instance. And the reason it can do this is because radar waves penetrate objects. So it can penetrate, obviously, dust and things like that. They can also penetrate a lot of the objects that are in waste containers. And various materials also have different reflective values. And that means that the signal that we pick up is very information rich. But as you can kind of see from the image on the screen here, it is also pretty much incomprehensible to the human eye. And so we send the signal to our cloud solution, and kind of that's where the magic happens. So our machine learning algorithms analyze this and pull data and information out of this, so that we can do a lot of really cool stuff. We can automate things, we can give insight that just wasn't there. And that insight begins with data points. Data we collect from these containers. And we have millions of those data points. We collect them from live field data, where we collect thousands, tens of thousands of samples every week. And we collect it from artificial experiments. Because obviously there's a lot of edge cases that are about to occur that you need to, they will at some point occur in live field data, but to really be able to train the algorithms, it's good to also generate them. And so, if you took a machine learning or mathematics degree at university, you might think that you'd spend most of your time just sitting at a desk. But if you're doing this in the waste management industry, you will literally get your hands dirty. So these are pictures are our machine learning engineers who are picking up trash and putting it into containers to gather the data and the information that we need to train our algorithms. Because what we use is something called neural networks. And so neural networks take input data and then compare it to training sets where we also have the correct answer. And by doing that, it can compare what it thinks is the right answer to what is the right answer, and generate these lines, these connections to the neurons in the network, enabling it to see the things that we don't see, be able to pull this information from it. And that can generate a lot of value for a lot of players in this value chain of waste. And one of them is the construction site. So a construction site, as I said, generate a lot of waste. And they also waste a lot of time on handling that waste, because if it's not handled correctly, it can cause problems. So at a construction site, you might have an engineer whose responsibility is to handle this. You might spend up to 5 hours every week just keeping track of waste collection, keeping track of waste production, making sure that it doesn't go wrong. Because if it goes wrong, then you get this. You get overfill containers that the drivers from the waste management companies aren't allowed to pick up, because obviously driving around with this is a hazard. And so the construction site has to take workers who should be building, and instead having them have to organize and sort out this waste. So there's a lot of, if it goes wrong, there's a lot of issues that can happen. And so I thought I'd show you a video here of what this looks like in real life. So what you can see on the left-hand side is the measurement from our sensors, and on the right hand you can see a video of what's actually happening. And what happened here is that very rapidly the container fills up our sensor picked it up, it sent an order, and it got picked up, and the cycle starts anew. And I think what's interesting is how quickly that container actually filled up. It went from sort of being half full to being entirely full just very rapidly. And that means that, if the person who was responsible for this on a site without sensors, they kind of had to be on the ball nonstop, because they're off site, it fills up, it overflows, they have a problem. And that's the really valuable solution that sensors can provide. And so what we call this is fill level monitoring, which is one of the features that we provide to our customers. So we do automatic pickup orders, which save a lot of time for these people on the construction site. But we can also optimize logistics and production for the waste management company. So for the people who plan transport, plan the driver's route, they can see that containers are filling up. So if they have a full container quite far away from their materials recovery facility, they can see, okay, we need to drive very far. Is there something we can pick up along the way? Something that might not be entirely full, but within a day or two, it will be full. And so on the way, they can pick that up and drive less, pick up more, and just be more efficient. And for the people on the production side, they see how containers are filling up and can predict that as they're seeing the containers fill up, they know that within a day or two, they will get a lot of containers onto their site that they will need to hire, that they will need to sort out. So they might need to bring in extra people, for instance, if there's a lot. And it also provides better information for the end user, for the construction site, and for the construction companies who might want to take this data to report on ESG, for instance, to compare their actual waste production with the waste plans that they generated before the start of the construction period. So that's one of the things that radar does. But GPS is also a very valuable sensor in this, because you would think that large metal boxes that weigh hundreds of kilos would be easy to keep track of. But as this Dutch waste management company that we talked to said, they're like flies. They lose them, they misplace them, and there is no real digital representation of an individual container. So it's very hard to actually keep track of them and understand what's going on. And so that's why we do asset tracking. So obviously we do accurate and up-to-date location so that drivers can have assistance in finding the container. If they lose them or they're stolen, they can be easily recovered. You can also do things like automatic inventory management. Today, people have to walk around and count containers. And the only thing they know is by the time they put that number they came up with into a spreadsheet, that number is probably wrong. But with a real sort of digital twin representation of each container, they can do this automatically. They know how many containers they have of each type. They know what the usage percentage is. They know that, okay, on this part, in this department, we have too many. We can move this to another department. They can be much more efficient and get more usage out of the inventory they have. And finally, having a digital twin also has a huge health, safety, and quality benefit, because you can actually track the state, the condition of a container, the status of it, the customer usage. So you know that this particular container has an issue. You don't have to, and you can find it easily, and actually keep track of it. So if something's wrong, you know which one it is, and you can find it. And there's also a lot of some container types need to be externally certified by a certification board. And today, updating those certifications are essentially a reactive process, because there's a date stamped on the container, and you have to look at the containers to know when it expires. And that means that they'll be reactive, often quite ad hoc, and can be quite expensive. But with digital twins of these containers, they know when recertifications are coming up, they can group them together, they can make sure that they're all gathered in one place and just make it much more efficient. Now, to come back to the point I made earlier about 58% of companies being unsure of the use of secondary material, of course, the goal should be here that 0% of them should worry about that. They should know that the material flow and the quality is as good as they need it to be. And that's where we're going to go next with a feature that we're currently developing called material analytics. Because as I mentioned earlier, various materials have various reflective values. And that means that by taking this radar sensor, sending it to our cloud, and analyzing it there, our machine learning algorithms can identify what material in the container. And that means that you know what's coming in, you know where it's coming from, and you can proactively gather materials to have efficient production instead of taking it as it's coming into the facility. And with some customers who want to use secondary materials, obviously they also want to make sure they know where it's coming from. You can't use polluted wood to build new children's furniture, for instance. And so you need to be able to actually have some sort of traceability of where the wood comes from, to be able to pick up the wood from the right places to produce the materials for certain customers. This is something we're developing now, and I'm very excited about it because I think it's a way for us to make this flow much more visible than it is today. So to close off, I wanted to give a little preview of a new version of our dashboard that we're working on and show how various participants or various employees at a waste management company might use this. And so what you see here is the asset tracking element that I've circled in yellow here. So this makes it very easy for someone working on this part of the business to quickly see how many they have, what the usage percentage is, how it's divided by different types of containers, and again, be proactive in using these, in moving them around between different departments, just have much more efficient usage. For the materials recovery facility, the people who are receiving this waste, they certainly have the ability to see what's going to happen, because they have this chart that's seeing how containers are being filled up in the field. They see that the red bit, the full containers are increasing. They know that these will be picked up very shortly and be on their way in, so that they can make sure that they staff accordingly and plan accordingly for that. And finally, for the people working more on the administrative side of things, they can keep track of how their orders are happening. They can keep track of any issues coming up, like containers that need to be recertified, for instance, containers that might have issues, etc. And utilizing that digital twin functionality to get a better overview. And I think some quotations from our customers really sum it up. It is a revelation to be able to see this. It enables people from the very top to the very grassroots of these organizations to see things and understand things about their business that simply just wasn't visible. I think that's one of the reasons that Sensorita will revolutionize this industry. And if anyone listening to this has containers and want to help them manage themselves, then get in touch, and we'd be happy to help you do that.
Thank you, Henrik, for a very interesting presentation about Sensorita and modern waste management through machine learning and IoT. And now we open the floor for Q&As.
Should we just start answering the questions? Amina?
Yes, definitely. We have some questions.
Yeah, cool. So yeah, so we have a couple of questions around the reliability and harsh conditions. So we can start with harsh conditions. So it's designed to take that impact that it is that is that they're exposed to in conditions. So we've tested this on the 200 G that you can that a container can have the impact when it's dropped, for instance. And so the sensor is designed to take that sort of impact. So, for instance, you can drop a 5 kilo metal ball from about 1.5 meters, 2 meters down onto it without it cracking. In terms of reliability and measuring waste levels, that is the cool thing about radar, because radar does have a conical spread, so it covers a very large part of the container, and the radar signals penetrate objects. That means that even though there might be, the waste might, for instance, be heavily weighted towards where the sensor is, the sensor is able to see what's behind the materials in front of it. So yeah, when it comes to the question from Rune, that it has primarily been tested on site, so not a lot down into basements. But Martin might have some insight into how because it gets also the second question, network communication. We use LTE-M, and so Martin might have some insight into how LTE-M penetrates into buildings for communication.
Yeah, so with regards to LTE-M penetration, can the containers be hidden away in several stores underground? I think it's not possible to guarantee that it will always work. So here a site survey might give you the correct answer, but using LTE-M should provide you quite good coverage, but it's not possible to guarantee a particular case upfront.
Can be grouped in logical groups. So the software solutions or our platform allows you to group the containers in on sites, for instance, or geographically where they're placed. I'm not sure if that's exactly the question you have, Sabir, but there's a combination of sort of static metadata, so the container types, which is obviously one type of logical group, and then dynamic metadata depending on location.
All right, I don't think we have more. Okay, there's a question coming in.
So we have an API that so you can't connect your sensors to your cloud platform. But you can connect your cloud platform to our cloud platform through APIs, for instance. Oh yes, yeah, so that's the question on connectivity. Battery life. It's So the theoretical battery life is actually longer than the 10-year battery life that we're working with, but obviously it's hard to give you know, sort of 2 lines on the answer to what the real life time will be, because they obviously haven't been in the market for 10 years. But we are, when we work with 10-year battery life, we are going below what the theoretical battery life is. Regarding type of waste on site, so at the moment that is done by the users, so they need to report that. And when it comes, but with the material analytics functionality that we currently have in development and are planning to launch next year, we will also be able to dynamically detect the waste type and group it. When it comes to cost, it's probably best to reach out and we can have a meeting and discuss your needs.
Right. There's a question about the status or initiative for supporting NuSim. So Com4 has been a NuSim initiative partner. First one after DT launched this. This ecosystem has been waiting for availability of hardware, but now there is some hardware supporting NuSim, and we see the first deployments. At Com4, we're quite happy to discuss with any interested customer or prospect to discuss whether NuSim suits for you and whether we can trial this in a demo and eventually go live with this with you as a customer. So thanks, Eirik, for the question.
Sabir, I think happy to, yeah. So my contact details, I think both for Sabir and Prince Shadrach Okoye. I'm sorry, I can't pronounce your name fully there. Yeah, you can get my contact information is henrik@sensorita.com, and feel free to send me an email and we can discuss any particular needs you have in a one-to-one meeting.
All right, I don't think we have more questions for today. So we'll wrap up this session. So I would like to conclude this interesting webinar on the future of IoT connectivity by saying thank you to Martin Noor and Henrik Holland for sharing their expertise and knowledge with us. And to the attendees, thank you for being part of this event. I will send out a complimentary report summarizing the key insights from today's session, as well as the recording of the webinar. So our next webinar is scheduled on February on the topic of 2G and 3G sunsetting, and more info will be sent out by email. So please stay connected, stay informed, and hope to see you again during our future webinars. Have a great day. Bye-bye.